If you're viewing on YouTube, please press like and subscribe. And if you're viewing on BitChute, please view on YouTube as well. Also, same to you Twitch followers. There's lots of exclusive content over at youtube.com/smAsho, so make sure you subscribe over there. Tell your friends, tell your foes, tell your science noobs, and your science pros. And if you didn't see yesterday's Daily Space Weather Supplemental, we reported on additional coronal mass ejections occurring. We will leave that on the end screen today, so you can view that if you didn't. Some spectacular imagery of coronal mass ejections. And thanks to our subscribers over on BitChute. If you're only viewing on YouTube, view on BitChute as well. There's exclusive content there. And let's go into a cosmology segment. It's quite full of information today. We won't be doing anything random, as is there anything really random in the universe anyway, folks? First of all, how about an unprecedented map of the sun's magnetic field, including the mysterious chromosphere? Yes, this SciTech Daily article talking about the Clasp 2. Normally, we'd only be able to see the chromosphere during the times of a solar eclipse, but fortunately that has changed. And I'm just letting the SciTechDaily.com article here scroll. The Clasp 2 is a small suborbital rocket, and it's helping to reveal the magnetic fields. So the chromosphere is the area in between the corona and the photosphere. It's the part that we're looking at when we look at those different wavelength views, like 304, 171 angstroms. And the Clasp 2 revealing some of the magnetic structure of that. And since the sun is the Rosetta Stone of all cosmology, this is super important, and it's part of the reason why we cover heliophysics on the daily. And I'm not going to get into what's going on with that, the Zeeman effect. I'm not even going to go there. I'll just put up this diagram to show you the solar layers. And move on. Again, that article's on SciTechDaily.com. And now I don't know what we're looking at. We're not going to be talking about the inner ear today. All right, let's continue on here. To talk about Cygnus X1. So Cygnus X1 is the first object widely believed to be a, quote, black hole, end quote. I prefer not to use that term. I prefer to use massive radio source. Here it is on the Swift Bat Flux. It is a very bright X-ray source located in the Milky Way galaxy, once believed to be at about 6,000 light-years distance. There's an article here, of all places, on extremetech.com. And according to a newer survey, this object is about 1,000 light-years farther away than expected, therefore significantly larger than originally believed. This is the same, quote, black hole, end quote, that Stephen Hawking and Carl Sagan famously betted on. Once believed to be about 15 times the mass of the sun, now believed to be about 21 times the mass of the sun, as this massive object orbits a supergiant star. So that's just an artist's rendition right there, folks. If you want to read about X1, that one coming out a couple of days ago there on extremetech.com. Speaking of massive radio sources, to which some refer as black holes, how about a sky survey of ultra-low, well, not ultra-low, but low-frequency radio waves featuring 25,000 black holes, a large portion of the sky mapped in 250 megahertz and lower radio frequency. So this one's on Universe Today, and the low-frequency array is a series of lots of telescopes across Europe, and they're measuring, again, below 250 megahertz, which are the lowest radio frequencies able to be seen from Earth. And so another fascinating image here. It's got 20,000 antennas located at 52 stations across Europe. And it takes a lot of computing power to tie together all of that radio frequency data. A very detailed image of 25,000 black holes across the night sky. And there is that image once again. Fantastic cosmology story. And continuing on, we've got one more. Mysteries of the Milky Way are revealed in spectacular detail. And we ain't kidding. Talk about a high-resolution image. This one is 50,000 by 25,000 pixels, and there is a link on this article to the zoomable version. So if you'd like to zoom in on the bulge, the central bulge of the Milky Way galaxy, head to scitechdaily.com. And here's the part of the sky that it is. Now wait a minute. There it is. There you can see the central bulge of the Milky Way galaxy. It's just this tiny little section, but it's very high resolution. Here's a tidbit. That wasn't a tidbit. Haha. So I zoomed in on one of the void areas. So you can see that void right there. It's got some massive hot blue stars in there. And check it out, folks. It must be an alien spacecraft. A series of alien spacecraft here. Oh my God. Who would have known? Who would have guessed a bunch of alien spacecraft showing up there around the extremely highly populated core of the Milky Way galaxy? Just kidding, folks. Those are some kind of artifacts. But that's a great spot to zoom in on. Some fantastic detail. And you can zoom way, way in to this massive high-resolution image. And again, you can link to that at scitechdaily.com. Some great articles there today. Nice combination of stars in this area. Some blues, some reds, some oranges, some whites, and some yellows. So that's today's fascinating cosmology